Okay, so I'm going to start off on explaining to you section 1, which is reaction time. And in this section, we only have one word, reaction time, which is the time it takes to respond to a situation. Okay. This section also talks about the amount of time you need to react to a situation has a direct impact on your driving ability. It takes time to notice a situation and more time to respond. A person who requires more time to respond to what they see or hear is more likely to have an accident than someone who responds in a shorter period of time. Okay? Now we're going to go to the second section, which is measurements. Measurements their words are random error, which is an error that cannot be corrected by calculation. We have systematic error, an error produced by using the wrong tool or using a tool incorrectly for measurements and can be corrected by calculation. We have accuracy, which is an indication of how close a series of measurements are to an accepted value. We have precision, an indication of the frequency with which a measurement produces the same results. And we also, this section consists of how measurements are never exact. All measurements have systematic and random errors. We have section 3, which is average speed. In this section, we even have formulas. We have a formula for your average speed. And average speed is the total distance traveled divided by the time it took to travel the distance, meaning that if you want to figure out your average speed, you have to take the distance traveled and divide it by the time it took to travel a distance. We have speed, which is the distance traveled per unit time. Speed is a scalar quantity. It has no direction. We have constant speed, which is speed that does not change over a period of time. And we have instantaneous speed, that is the speed at a given moment. We also have velocity. It's the speed in a given direction. We also have the Doppler effect, which is a change in pitch. And we have reaction time, which is the distance that a vehicle travels and the time it takes the driver to react. This section consists of when you drive an automobile, you're controlling its velocity. You change the automobile's velocity by changing its speed. You are continuously monitoring the automobile's velocity, and you adjust both speed and direction as necessary. Now we have section 4, which is graphing motion. The concepts we have is acceleration, which is a change in velocity with respect to a change in time. We have a vector, which is a quantity that has both magnitude and direction. We have negative acceleration, which is a decrease in velocity with respect to time. The object can slow down or speed up. We also have positive accelerations, which is an increase in velocity with respect to time. The object can speed up or slow down. We also have a formula, which is acceleration equals change in velocity over change in time. There's also a tangent line, which is a straight line that touches a curve in only one point. Now I'm going to show you graphs that can help you understand all of these terms. Here, we have a constant speed of accelerating. Here, we have we have a negative acceleration because it's starting here, and then it's starting to go straight, and then it's slowly going to come back, so there's a negative acceleration. Here, we have a constant speed. The speed never changes. And then here, we have a negative acceleration because it's just going downhill. And this is also a positive acceleration. And this is also a positive acceleration because it's starting slow then goes fast. This is also an example of a tangent line right there. Oh, and this section also consists of how driving is all about acceleration. Automobiles accelerate when they speed up, slow down, or make a turn. The negative acceleration is to avoid accidents when they apply the brakes. Speeding up too quickly can also lead to accidents. Okay, now we will go on to section 5, which is negative acceleration. Here we have negative acceleration, which is a change in the velocity with respect to time of an object by decreasing speed in the positive direction or increasing speed in the negative direction. This section consists of how if you triple your speed, the automobile will require triple the braking distance. So it takes more than triple the braking distance in order to brake safely. Now we will move to section 6, which is using models. This section is about the go zone, the stop zone, an overlap zone, and a dilemma zone. I'm going to just break them down for you so you can understand, okay?
Mm-hmm.
Okay, the go zone includes all positions where the automobiles can safely proceed through an intersection when the light turns yellow. The stop zone is when it includes all positions where the car can safely stop before reaching the intersection. Overlap zone is when the light turns yellow. The driver of the vehicle has a choice of either stopping or going through the intersection safely before the light turns red. A dilemma zone is a space between the stop and go zones. This section consists of how we learn that an automobile travels a certain distance while you're moving at a constant velocity and deciding whether to stop. We also learn that an automobile travels a certain distance after the brakes have been applied. We also learn that deciding what to do when you see a yellow light is not a simple decision. It requires a judgment of the distance to the intersection, the withdrawal of the intersection, and how much time it will take you to get there at the speed you are traveling. Now we have the last section, which is section 7, and it's the centripetal force. This section has the physics concepts of force, which is a push or pull. We also have centripetal force, which is a force directed toward the center to keep an object in a circular path. We also have a centripetal acceleration, which is a change in the direction of the velocity with respect to time. This section consists of how we learn that friction between the road and tires help keep an automobile on the road when it goes around a curve. More friction allows you to move faster and still stay on the road. A tight turn requires more friction or a slower speed than a wider turn. We cannot change or control the friction between the road and tires because a slower speed will keep the automobile on the road. And that's all. Now I'm going to ask you some questions and see if you understood all the sections. Are you ready?
Yes.
Okay, so in section 1, how does reaction time relate to driving?
Well, if the car in front of you stops, or if a pedestrian runs through the street, you won't have time to stop. So if you're not paying attention, that's why distractions are bad, because they affect your reaction time.
Okay, perfect. Now we have section 2. What are the difference between systematic and random errors?
Well, random error is an error that cannot be corrected by a calculation, and a systematic error is produced by not using the right tool.
Okay, and why is there always going to be an uncertainty in measurements?
Because there's not always going to be an exact measurement, and because people always use different tools.
Okay, and now we have section 3. How are the speed and velocity of an object different?
Well, the speed is the distance traveled, and the velocity is the speed and the direction of the distance traveled.
Okay, why is it important to keep a safe distance?
Well, it's important to keep a safe distance because if you don't keep a safe distance, maybe the person in front of you can suddenly stop and you might run into them. Not run into them, but cause a collision.
Okay, now we have section 4. How do drivers depend on negative acceleration?
Drivers depend on negative acceleration to avoid accidents when applying brakes.
Okay. In section 5, how will negative accelerations help you?
Well, they can help you to stop properly at a stoplight.
Okay. Section 6. If all traffic lights stayed yellow for the same amount of time, how will this affect drivers' decision at intersections?
If the yellow lights is always the same amount of time, it can affect the driver's decision when they run through the next yellow light to calculate if they have enough time to pass through it or to stop on time.
Okay, and the last section. Why do you have to enter a curve slowly?
Because you don't know if there's probably a car coming in the opposite direction, and if you go too fast on a narrow curve or sharp curve, the car might go over the edge or flip.
Okay, perfect.